Okay, in this video I'm going to talk about the importance of establishing a whole. I'm going to also talk about the kind of ways that we want to develop language with our students, especially the academic language around mathematics. This is for English learning students, but I'm going to make the argument that when it comes to mathematics, most students are learning to use the language appropriately. And so this is for all students, really. So the first thing that I want to do is to establish the whole. And here's what I mean by that. If I take this Cuisenaire rod and I say, okay, this is equal to one whole. Now you might ask, so if that's the case, if the blue rod is equal to one whole, then what's the value of this light green rod? And so I would like students to be able to use the blocks to say, well, if you look at these blocks, you can see that 3 of the light greens have the same length as the blue, and because 3 of the equal-sized pieces have the same value as one whole, we call that 1/3. Now here's an important thing I want to say, because 3 equal pieces make one whole. Now, why is that so critical? And why is it critical? Well, it's critical to write that sentence because you want students to be able to refer to that language specifically. It's very precise language, and this is about developing their cognitive language or their conceptual understanding through language. But I want to underline something and maybe even put an asterisk next to it. Those have to be equal pieces. And here's what I mean, and here's why that comes about. Because if a student were to build an equivalent structure and say, look at this, those pieces are also equal to one whole, and there are 4 of them. So would we then say that each of those is equal to 1/4? Well, we know that can't be true because we're going to have 2 different sizes with the same value. And so here, the reason each of those is not equal to 1/4 is because they're not equal size pieces. Only when we have equal size pieces, like this, can we say that it's equal to 1/3. Okay, so the light green is equal to 1/3 because 3 equal pieces make one whole. It's really important to write that down for reference, for students' reference, also for yours, to be honest. I write it down for my own reference as well. Once we have that established, then we can start to ask our students questions. If that's 1/3, then we might be able to ask them, well, what value is this then? And this is when we want students to be able to build from unit fractions. And so this is equal to 2/3, like this. There's 1/3, and there's 1/3. And that makes 2/3 because 2 pieces each with a value of 1/3. That's why that's called 2/3. Now, you might also have other activities where you ask students to build a model of, say, 1 2/3. So what does build a model mean? It means, well, use our manipulatives to build a value that has 1 2/3. This is the easiest, but not the only way to build 1 2/3. There's 1, there's 1/3, there's 1/3, and so this has a value of 1 2/3. Alright, so what have I said here so far? How important it is to establish a whole, how important it is to compare parts to the whole, but when you're establishing the values in terms of fractions, they have to be equal size parts, and then you can use those understandings, those values, to build a new number. what's important here is that you put this in a place where students can refer to it, and you train them how to do it themselves, do this themselves. That's going to take time. Now, I want to also point out something. What if I said to you that this block is equal to 1 whole? Then what would be the value of this block? Well, using the same method that I used before, I would put these blocks together and I would say, oh, look, since 3 equal-sized pieces, so that's equal to 1/3, because 3 equal pieces make 1 whole. Now this is where conceptually the most important part of Cuisenaire rods comes into play. If a student comes up to me and says, well, teacher, how can this be 1/3 and how can this be 1/3? They're not the same, so why are you calling both of those pieces 1/3? And my answer is, well, this is 1/3 if that's the whole, and this is 1/3 if that's the whole. An important piece of information for students to learn, and this is very difficult. It takes probably weeks and months of repeated understandings, is that values, fractional values, only have value when compared to the whole. And so before somebody says to me, what value is this block? I have to ask them, well, what's your whole? Because if this dark green block is your whole, then that value is 1/3. But if this blue block is your whole, then this red block has a different value. So this is a very important concept. The fractional value depends on the whole. Another way to say that in kid language is this. I can't tell you the fractional value. I can't tell you what the value of a block is until you tell me which block is the whole. All right, that's enough for this video. Thank you for listening.